Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean is the simplest cloud platform for developers and teams with products like Droplets, Spaces, Kubernetes, load balancers, block storage, and pre-built one-click apps. You can deploy, manage, and scale cloud applications faster and more efficiently on DigitalOcean. Whether you're running one virtual machine or 10,000, DigitalOcean makes managing your infrastructure way too easy. Head to do.co/changelog. Again, do.co/changelog.
Let's do it. It's go time.
Welcome to GoTime, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the GoTime FM channel and Go for Slack. Follow us on Twitter. We're at GoTime FM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Hey everybody, welcome to GoTime. Today we are bringing on a guest, Dan Scales. You want to say hi, Dan?
Hello.
And then we have our normal panelists, or some of them, Matt Ryer.
Hello.
And Carmen Ando.
Hello.
And myself, John Calhoun. So today we're going to be talking about Matt's favorite subject, defer. So Matt, I'll let you go ahead and kick it off. What do you want to know about defer today?
Well, first of all, it genuinely is my favorite feature of the language.
Nice.
Yeah, it stands out because it just has this kind of readability aspect to it. Apart from it, the functional kind of use of it, it makes it so clear what you intend. And anything that does that, I always think is great. And so defer is a great example. For anybody that might be new to Go, who doesn't know what defer is, I'm happy to give a little overview from my perspective, and then we're going to definitely dig into it deeper with Dan as well, which I'm looking forward to. Yeah, so essentially, you tell it to call a function when another function exits. So when you leave whichever function you're in, anything you've deferred will then get called. So it's a bit like saying, defer this function, and however you exit from this, then, we want the defers to run. And that's nice because, we'll talk about, I suppose, use cases. Yeah, so the use cases actually then of this simple, it's quite a simple little thing, I think, but has kind of amazing utility.
Yeah, definitely. I think it solves a problem that you kind of run into if you don't have it, which is you want to take care of some things at the end of the function. You want to make sure they get done, and you want to make sure they get done even as the code changes and evolves, right? So it helps with maintainability. You want to put right near, you opening a file, you want to put right near that statement where you open the file, you want to put something that says, I need to close the file at the end of the function. And, the classic way in, say, C or something is to, at every single exit point, you got to put a close there. And, the defer is just a really nice way to express it. And it's right near the open. So it's very well expressed. And you can contrast it with other language features like a try finally in Java or JavaScript, which is doing something similar. A try finally is another contract which says, do some code, and at the end of it, make sure you do something in the finally clause. But that stuff in the finally clause is pretty far away from where you did the open. So just as you said, one of your nice things is right there, and I agree with that. It really makes it obvious. I want to get this done, and it needs to be done.
And with try finally, you could easily end up nesting things quite a lot. If you're trying to open a few files and then you want to make sure they're all closed, and maybe you're making some API calls as well and doing a few other things, you can end up with really sort of deeply nested try-catch blocks all over the place. And one of the things defer gives you is that it doesn't do that, does it?
No, exactly. It's not nested in that way. And, I think because of the nesting, you can either do that nesting or because people don't really want to do the nesting in the try finally, usually they put a lot of conditionals in the finally block. So what they'll do is they'll have one try and they'll usually say, if this file handler is not equal to nil, which means I did an open earlier, then I'm going to close. Does that make sense? And so they'll have a whole bunch of conditionals. And so the nice thing about defer is you don't have those conditionals. You just, at the point where you actually open the file and you definitely did it, then you put the defer and then the Go will take care of running it exactly when you actually did the defer.
I used to think that defer was a compile time operation where it literally just copied the code at the exit points. But of course, when you consider that you can schedule defer statements inside loops and all sorts of things, and conditionally, so yeah, it isn't that, is it?
No, exactly. Yeah. So it's definitely much more dynamic construct than the try finally, or we can talk about the kind of the equivalent in C++ in a little bit. But those are kind of more static constructs, and therefore the compiler knows everything. And when and where you run that finally clause is of course determined. But the defer, the compiler doesn't know if you're actually going to need to run the defer if it's in a conditional or a loop. And so, yes, so the implementation in Go has to account for the fact that it can be dynamic. And so you have to have kind of a general implementation that depends somewhat on the runtime in order to deal with those dynamic cases. And then the optimization that we've been doing over time is to kind of deal with those simpler cases more statically. And so that's, of course, the optimization we'll talk about later that I did does kind of what you said, which is in the simpler cases, actually run that code right at the exit, as you might expect in the non-loop cases.
I see. But where it's more complicated and it can't do that, it falls back to the previous mechanism.
Exactly. Yes.
Oh, yes. That's very cool. So you mentioned what you did. Maybe you could just tell us a little bit about where you work and what you're doing, a bit about what you've been doing as well. It'd be quite interesting to hear about.
In the past as well as in the current Go group, or?
Yeah, sure.
Yeah, so I've always been interested in kind of low-level system piece stuff, both parallel and distributed processing, operating systems, but also compilers and languages. So I've kind of been doing a little bit of the circuit and some kind of parallel and distributed work in PhD thesis and work after that. And then I was at VMware for a fair bit of time and did a lot of operating system stuff. But that kind of involves distributed systems as well, because we do a lot with high availability and keeping virtual machines highly available and restarting them and so forth. And also at VMware, I focused a fair bit on high-performance storage and virtualizing storage. So did quite a variety of stuff. And then, I wanted to get back to kind of lower-level stuff like compilers and system stuff after doing other things for a while. And so I transferred to the Go team about a year ago within Google and just was interested in doing languages and compilers. And I have done compiler work in the past. So I've worked a fair bit of time on some stuff to help optimize Go usage in Google itself. And then in the last 6 months or so, I've been, working with the compiler and runtime people and kind of a newer person compared to a lot of the more senior people here. Got this very interesting project to optimize defers further. Yes.
Well, that sounds great. And this project to optimize defer is a kind of a great one, because one of the things I love about the way that the situation is at the moment with Go is that we can use these language features somewhat liberally, and I tend to use them somewhat liberally. And sometimes there's like a trade-off between the performance and the readability. And so, occasionally it's worth having very difficult to read code if, in your particular case, it's valuable that it is very performant. And so I get that for sure. And there are some times in my code where I've eventually optimized away some defers, but mostly not. But what were the performance issues? Like what's the actual problem?
Yeah. So it's, defers in general not amazingly expensive, or, and they've been optimized quite a bit over the last couple of years. There have been a number of steps of optimization. So, in most cases, you don't see the overhead, but there are some very common cases where you do see the overhead, and that's when you defer a function that's fairly inexpensive. And, one of the most common cases is lock unlock. And that's, so an unlock operation is very inexpensive in the common case when you hold the lock, of course, because you're basically just sort of setting a lock to 0. But we don't want to discourage people from doing that because that's a perfect usage of defer. So we want to optimize defer. So in the common case, in the cases where it's not so dynamic and you can analyze everything, we want to make it very inexpensive so that you don't even see overhead or much overhead for, deferring an unlock or say deferring an atomic operation. Or, often I see, maybe you have a parser and, you kind of bump up a nesting level at the beginning of a function or something and you defer the bumping of the nesting level down. So all those functions can be very inexpensive. And so you want to make sure the defer overhead doesn't dominate those functions. Of course, you could use defer in other cases for open and close of files. That doesn't matter as much because an open of a file is probably somewhat expensive. And, another way to think of it is we also want to be closer to what C++ say is. And C++ has a kind of an equivalent feature, which is basically it guarantees to run destructors of variables when you leave the scope of the variable.
So is that where it's a class that has a destructor?
Yes, exactly. So you may allocate just a normal object, for instance, and it has a constructor, and you declare the variable at the beginning of the block. And if that class of that variable has a constructor, you run the constructor at the time that you kind of enter the block. And then C++ guarantees that you will run the destructor at the end of the block. And that may kind of deallocate sub-objects or whatnot. And the main thing is it guarantees it no matter what, whether you return early from the function out of the block or also, again, like defer, if you're panicking. And that's especially important, just like defer, if you're kind of holding on to a resource, which is a common case for whether it's a lock or a file. And so C++, one of the acronyms that's used that came from, I think, Bjorn Trustrup is resource acquisition is initialization, which is called RAII. But in any case, he's basically just saying that you can express kind of acquiring a resource and then guaranteeing that you're going to release at the end of the block by initializing a variable. And so what people do is, for instance, they might have a class which is basically a lock, and they acquire it at the beginning of the block, and then just by exiting the lock is released. So all that was kind of a description to say, well, C++, especially GCC, has made that overhead basically 0. They do the right thing. They generate code at the end of the block that just calls the unlock call. And so, it's very low overhead for that. And then they do the extra work to make sure it happens at panic time. And so, if we can get closer to that just all the time, then people don't have to think about it for defer as well.
That's very interesting. It's funny, you mentioned a little nugget there, which is something that surprises a lot of people, I found, which is that, of course, well, not of course at all, actually, and this surprised me in the beginning, but when code panics, the defers still run. And that's actually good to know. But I suppose also speaks a little bit to defer's history, doesn't it?
Yeah, so if you want to get a little bit into the history, I think, and I'm not the super expert on this, but I've been asking around, I think, most errors are handled using error returns, as people know. But there is always a need for a panic because there's always a case where you run into a bug or, say, divide by 0 or something, and you're going to have to do a panic because there's no kind of logical way to continue immediately. So the creators of Go knew they had a panic, and they knew they kind of had to have mechanisms to deal with it. In particular, sometimes you actually even want to recover from a runtime panic. And one case for that, you might say, well, yeah, this is a bug. Why do you want to deal with this? Most of the time you don't, but you want to just let the program crash. But suppose you have, a web server that has multiple threads and they're handling requests. And, you want that web server to be kind of reliable and up, even if there's maybe a bug somewhere. And so you have multiple Go routines serving requests, and one of the Go routine may run into a bug and panic. You may still want to do what's called recover. You may want to kind of catch that panic on the way out and, just say, okay, I'm just going to kill this Go routine, but I need to continue the web server. So the creators of Go, and in particular Ken Thompson, said I knew he kind of wanted to deal with maybe deal with panics and maybe have some way of recovering them or modifying them. And so the defer was a way to do that. And so one context for defer is it's a way to run code as you're doing a panic, either to release resources, which are important, and it's especially important if you're going to do a recover, which means you want to release resources that might be otherwise held by the web server that's continuing. And then also you may want to do this recover step after you release resources, which says, okay, I want to keep running. I don't want to kill the entire program. I want to kind of recover out, kill my Go routine, and then, maybe spawn another Go routine or whatnot. Yeah.
Well, the default behavior is that if a panic happens inside an HTTP handler, it just prints the panic out into the terminal, doesn't it, and carries on. It doesn't crash the program.
I think because there's a recover there.
Right. So they've recovered it in the standard library.
Yes, exactly. Yeah.
I know, one of the things I've found panic recovery useful for is if you're using another library that you don't have control of and you can't change for some reason, and they happen to panic at some instance where you don't fully agree with. Mm-hmm. I know I found that really useful is okay, I can actually capture this in my code and handle it in some better way or do something better about it. So I think maybe it wasn't what they were thinking about, but one useful side effect of that is that you can use code that you don't necessarily agree with how they handled their errors, and you can still make use of it and not have to recreate that entire library or whatever it is, because that would be a massive pain if that's how it worked all the time.
Yes, that totally makes sense. Definitely. The code that you don't have control over has a bug in it, say. And so for certain things, you want to make sure your program doesn't crash if they have a bug in their program, or as you said, you don't agree with the error that they are indicating.
So at a high level, does somebody want to go over just what that recovery looks like why we need to use defer, how you would use defer? Because I know we've talked about it. I'm guessing most listeners have seen this, but just at a high level.
Yeah, well, you tend to use an anonymous function, don't you? So you defer the function and do it in line. And then there's a block. So you have a kind of, at the top of the function, a block of code that is in a defer, so you know that this is going to run at the end. And then you call, it's a built-in function, is it?
Yes.
I suppose?
Yeah, it's a function called recover.
And what does that return?
That returns, so there's a bunch of specifications on when that actually can successfully recover. For instance, it needs to be running in a top-level defer during the panic sequence. So as you said, if you have a defer in a function, that you maybe deferred this inline function at the top of a function, and now you had a panic, say the current function called a bunch of functions and had a panic. As you're doing what's called stack unwinding and running your defers, if you run into a particular defer that directly calls recover, then you can successfully recover that panic. And with that successful panic, the recover function will return the value of the panic, what you supplied to the panic. And it could be, an error object or a string or whatever. And that defer function finishes, and as long as it finishes successfully, then now you're kind of out of panic mode. And you'll finish any other defers in the function, and then you'll return to the caller. So you basically, the panic has kind of ended kind of all your functions up to the point of the recover. But the recover allows you to then return to the caller of the one that did the recover. And so, at that point, at web server, whatever, you can continue on.
Yeah. I think one of the cases I've seen that this combos really well with is using named return variables gives you the option to actually set a return value yourself then. So a lot of people I know will look at named return variables and, you have different opinions about whether or not you should use them. But one of the most obvious and most common probably use cases is when you need to recover from a panic and then you need to actually return some sort of error to say there was an error and I actually want this to turn into an error rather than a panic.
Exactly, yes. So you can translate kind of the panic error or whatever to a return value error. Exactly, yes.
This episode is brought to you by GoCD. With native integrations for Kubernetes and a Helm chart to quickly get started, GoCD is an easy choice for cloud-native teams. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale build infrastructure on the fly for you. GoCD installs as a Kubernetes native application, which allows for ease of operations, easily upgrade and maintain GoCD using Helm, scale your build infrastructure elastically with a new Elastic agent that uses Kubernetes conventions to dynamically scale GoCD agents. GoCD also has first-class integration with Docker registries, easily compose, track, and visualize deployments on Kubernetes. Learn more and get started at gocd.org/Kubernetes. Again, gocd.org/Kubernetes.
As a general rule, I try and exclusively use errors, and I try not to use panics at all. So it was interesting that that was where defer kind of came from, wasn't it? It was in order to be able to recover from panics that they needed this feature. Mm-hmm. Is that right, Dan? And so that's where defer came from for that case. It's just funny, in my particular case, I never use the panic, but I use the defer all the time.
Yeah, it was kind of a good combination that defer can be used for both recover and for the just kind of more standard ways of releasing resources. And we don't want to overemphasize the recover or the panic case, because that's certainly not the Go methodology. The Go method of having normal errors that you expect or whatever is obviously return values. And so you don't want to depend on panic recover as a way to return errors very often. They have to be very unusual, because that path is not optimized, right? And so the normal case of returning errors by return value, it's definitely, you can do it, and definitely is a good way of, as you said, of dealing with kind of packages you don't control and errors you don't expect and so forth. But yes, I think it's very nice that defer is used both for dealing with recover, but I would say even more importantly at this point, doing that the resource, releasing of resources and the guaranteeing of the function. That part is the one that is a really nice feature that helps you maintain your code and lets you do these interesting stuff.
For me, it's kind of like note-taking as I write code. Like, it's like, oh, I open this file, here's a little note to close it. And like I found, just in everyday life stuff, I'm better if I take notes like that. So it's like interesting that in code we can now express that and, very clearly say, okay, this is something I need to do. But I mean, you've already done it by doing that, which is really nice.
Mm-hmm. And I know people have their favorite constructs in different languages, try finally, whatever. But I do think defer fits well with the Go language. It's very explicit. Go tends to not have too many hidden functions or anything, or functions off and another thing. So it's very nice to just have that, explicit, this is what I need to do, and it's right near the open.
It's so expressive that I will go as far sometimes as to structure my code so that I can use defers. Mm-hmm. For example, if I do have a for loop and it's going to go and process a slice of things, I could just do the work in there and defer things. But of course, if you're in a loop and you're going to open a file, you might want that file to be closed before you open the next one. And so having another inline function that's just sort of called immediately, and then using defers within that function, it is an extra level of nesting, but the readability of that code that you get, the fact you can just use defers in that sort of very liberal way is so nice when it comes to maintainability.
And we've talked about in the past about glankability too, and just conceptual overheads. And I know that try finally might work for other people's ways of thinking, but I do think that defer is more of the human way of thinking. We just have a natural inclination to think about what done looks like when you start the thing. And we often lose in a try finally paradigm, at least when I did. I would forget. If I didn't make that or structure that or put that in now, it would, you would forget. And also the ability that your nesting, Matt, doesn't have, you can safely nest defer in a way that you can't do that with try finally.
Yeah, that's true.
It's also interesting how, I feel like the Go community has embraced the way defer works to the point that you see people writing code where you'll call a function to set something up and it returns a teardown function. So you'll very commonly see people like, okay, I called this and it returns teardown, and then I immediately called defer teardown. And the fact that people have noticed this makes such a big impact on readability, and I don't want to think about how to tear this down. The function that sets it up should have to deal with that, not me.
Yeah, that's the nice thing about that. When the function, it is about keeping the tidy up close to where you're allocating the resources. It's easy. It's literally easier It's harder to forget to do it, essentially. But I do love that pattern where you return the cleanup function. I do it a lot in if I have test helpers that are starting servers or anything. And you can hide a lot of stuff inside a function then and change it later without touching the API. You know that you've asked the user to defer this function, so you know that it's going to get called kind of teardown time. So you can use that and add features to existing things just by having that as a pattern. It's a great one. Context does it too when you do with cancel. You cancel.
Yes.
Yeah, and they ask you actually to defer that immediately regardless, I think, don't they? Because there's, with the timeout one, there's resources that are created that need cleaning up.
Exactly. Yeah, I like that pattern as well, yes.
Yeah. Another one that I use is if I want to like do some simple sort of debugging, sometimes there's one where I actually I mentioned this in one of my talks, and I heard later some feedback. Someone just said that they thought I was an idiot for this thing that I'm about to repeat now for some reason. But it was essentially, if I had lots of log statements and I was trying to debug something by kind of generating the logs and having a look at what's actually happened and sort of tracing really unofficially. And sometimes you have log calls peppered throughout your code. And it's very useful to just log something like either a string that's just a line of hyphens or something, and then defer the same thing so that you print out a line of hyphens. And then when that function defers, when it exits, it prints out the other line. So you can kind of then capture a little snapshot, and it's a really practical way of just having a look, given potentially a lot of output, just to have a look at specific functions. And if you mix that with the time, then it's quite easy to get a little timestamp at the beginning and defer printing or capturing in some other place, the now sub that time and see the duration then of how long that function took to run, things like that. Absurdly useful and very, very easy to express with defer.
Yeah, and especially nice to use with closures, with inline functions. You don't have to have a separate function you're deferring. You just have code right there. Yes.
Yeah, so that's a really interesting point. There's some interesting things around that, aren't there? So maybe you could just tell us a little bit about what literally is going on when we defer something. Because when does the function get called? And what happens if we pass an argument into that function?
Yeah. Yeah, I like the design of defer also because it deals with a little issue that you sometimes run into when you use these closures, these inline functions, which is, do you want to use the value of the variable when you sort of declared the function, or do you want to use the value when you ran it? And so defer statement is a defer keyword plus a function or a closure, an inline function, and then a set of arguments. And the semantics is you evaluate the function or the function pointer, not run the function, but you evaluate if it's like a method call or something. And then you evaluate the arguments, and you save the arguments and kind of what the function is, and you store them away so that they can run and exit. And so the important thing is you evaluate the arguments at the time of the defer statement. However, if you have a closure, a function with the func keyword, anonymous function, then you can also look at variables at the time that you run the defer, right? Because that can look at functions, local variables in the function. So you get kind of the combination of both worlds. If you want to make sure you evaluate a value right at the defer statement, and that's what you're going to use, the file to be closed or whatever, then you can use it as an argument, and then you're sure that value evaluated is what you're going to use at the end of the function. But on the other hand, if you want to look at local variables at the exit and how they've changed, then you can use the closure part and look at the local variable. And so that's exactly how you can do some of the timing tricks or whatever, or various things. You can change error values and so forth.
So the last part you were talking about, that is what they're doing. Like with all the error wrapping stuff, you see a lot of code that comes out now where they defer a function that will check to see if an error is nil, and if it is, they'll go ahead and wrap it at that point.
Exactly.
That's using that latter part where you're saying it's looking at what the actual error was, at that time, and that makes that possible because, you're waiting to actually look and see what the error was. But if they wanted to actually look at a value directly, then it would be the last set of parentheses. Whenever they call defer, they would pass something in there, correct?
Exactly. Yeah. And you often have bugs when people use closures, these anonymous functions. You often have bugs where they think they're using the value at the time kind of that they created the function, but they're really using it at the end. And so you get bugs when you're running them in loops and so forth. So it's nice that it separates out the arguments that you evaluate at defer time with the other stuff you can look at if you want using the closure. But alternatively, you could just have a normal function, in which case you don't get to look at the local variables, but it might be more useful in other cases. So that gets into the implementation, which is that however you're going to implement the defer, you have to run the arguments and evaluate the arguments and what kind of function you're going to be running at defer time and store it away. And then at exit time, you have to run that. So we can get more into the detail of the implementation whenever.
I've got one other question, though.
Mm-hmm.
So panics don't stop defers. Is there anything that will stop a defer from running, apart from, obviously, frisbeeing your laptop across the room might stop defers as well. But are there any other things you can do in code that will prevent defers from running?
No. Stack unwinding is guaranteed. I think there might be some kind of runtime abort that will, completely terminate the
OS exit
process
maybe.
With no cleanup at all. But otherwise, the guarantee is that you unwind the stack during a panic and do these defers.
Do they run on OS exit? I think that terminates it.
They run on Go exit, which is to exit a thread, and I'm pretty sure they run on OS exit as well. So I think it's a board. I have to check on that.
Them.
Yeah.
We can't stop them then. That's the thing. So we've got to be careful how many we start.
Yes, there might be other aborts. I mean, obviously they don't happen if you kill the process, and then there may be another kind of an abort that you can do, which is just end the But I think on OS exit they do, and they definitely do on a thing called Go exit, which is to terminate a Go routine.
You could probably open Slack. That would probably do it as well. That kills my computer.
I see. I get it. Yes. Or
Don't worry.
Pull the plug.
Don't worry. We'll edit in laughter later.
Right. I see.
Yeah. Don't worry, Dan. So here's another one that's a very practical thing. When you close a file, that function can return an error. So if you just defer calling close, we aren't catching that error at all sometimes. Mm-hmm. What's the right thing to do there? Yeah,
I think that's just a trade-off. I think Go tends to want to catch all errors, but a close error is kind of maybe slightly less interesting. So we want to catch the main errors. But, I think defer does give you the mechanism to deal with it, because instead of saying defer os.close or file.close or whatever, you can use a closure or an inline function and actually run it and get the error value and then merge it into the error return of the function. So you can, if you really want to find out that, the close failed, you can merge it in and make it part of the error return of the function. I don't know if you guys have ever done that, or I haven't particularly tried to do anything. I certainly have, merged errors into function, but not close.
You're not supposed to say the last bit. You're supposed to say, Matt, we can't help it. You're writing bad code.
Yeah,
I see.
Yeah, it could have made me feel bad. Yeah, I think I've done that and logged it just because I want to see what could happen, but nothing's happened yet.
Right.
So I'm still waiting. Yeah.
Yes.
I wondered whether it was that signature just to satisfy IO closer or something. Like there was some early decision to have a closer type. Is it IO closer? Yeah, I think so. A closer interface with a close method, and sometimes closing things, there can be an error, especially if it's writing and it's going to finish writing some things or something. Yeah. I wondered if it was just left over from that, but what can happen if you close a file, it just doesn't close? Then what? It's like, if we're not in control of the computers, Dan, do you know what I mean?
If you're doing a database, you probably do want to check the close, and probably in other situations, it probably is checked, because, during a close, you may not have written out the whole file. And so part of the close is writing out the final buffer length of the file, buffer amount of the file. And so, it is actually, to be really safe, you probably should be checking the error code of the close, and therefore, express the defer in such a way so you can modify the error code. Maybe you just open the file for read, in which case it doesn't matter so much. But fortunately, like unlock has no return value. Unlock basically always succeeds. So, defer unlock makes sense, and lots of other things, of course.
Matt, your code's going to get pretty boring if you just cut out everything you don't want to deal with.
Yep.
And it won't be very functional either.
He's already banned else statements and a bunch of other things. So
Well, no, I mean, please help yourselves. But actually, there's that trick of if you flip the if statement, you can sometimes, it's about dealing with the errors early and exiting early and keeping the line of sight down one edge really clear. That was the thinking behind it. Yeah. But actually, yeah, it's not. I mean, defer, I think, is just sort of stands out. And I think I saw it after, a few years after I was started with Go, I saw it turn up in the Swift language as well. It works slightly differently. I think it does it on the block. Is that right?
It is on the block level, yes. I haven't used it at all. It's kind of a little more integrated with the language in the sense that it actually is a defer and then a block, not a function, but it's a block of code. So, you can kind of think of it as a closure or an inline function, but it doesn't allow you to call a function call except if you put it in that block. Yeah, so it's interesting. They definitely adopted it from Go as far as we would guess, went with the block level, and that I think you could see it either way. One thing to note is you can't do conditional defers with that kind of a defer because you do an if and you have a block and then you do a defer. You're gonna immediately do the deferred operation at the end of the if, which is not what you want. So the Go defer runs at the function level. Is a little different. I can see it running at block level too, but it definitely is more useful for kind of these conditional cases.
Well, I kind of simulate that block behavior when I just have these little inline functions. That's kind of what I'm doing, really, because I am defining the block that I want the defers to run after. And so,
exactly.
Yeah, I think it is.
Yes.
So Go 1.14 has some little treats in it for us, doesn't it, Dan?
Mm-hmm. Yeah, so there are several performance optimizations, of which one relates to defer. And this is work that I did, and it was from some ideas from a bunch of people in the group. And the idea was, as we started talking about, is kind of make the overhead lower in the more common cases. And that's what's been going on in the last few releases. The defer has been steadily getting faster in some of the common cases. And so in this release, we wanted to make it even faster. And basically, you can think of it as we're running the function calls directly at the exit. So it's kind of the compiler is directly generating those function calls at the exit. It kind of just as I think you were saying, that's how you think of it. And in the common case where we can do it. But we also we can do that in most of the frequent cases of defer. So this optimization is not turned on if any defer in the function is in a loop. However, we do it if they're in conditionals. So if all the defers in your function are either just straight defers, no conditional, or they're in a conditional, then we will do the optimization that I'll describe. If any defer is in a loop, then we will not do that optimization yet, and we'll do kind of the standard runtime thing.
But do you have to copy the conditional then?
You want me to get into the details here?
Oh, yes, please, because this is way too interesting.
Yeah, exactly. So the notion is that at any defer statement, let me see. Let me describe the current way before the optimization. The current way is at any defer statement, what you do is you kind of create a record, a defer record, and in that record you evaluate all the arguments and the function pointer that you need to defer, and you put that information in the record, and you kind of add it to a chain, and a chain in the runtime that's kind of a defer that you're going to have to run later. And then at all exits, you call into the runtime and you run the appropriate defers. So there's definitely runtime overhead as you're kind of adding to the chain in the runtime, and then at the exit, you're jumping into the runtime and saying, run all the defers that are on that linked list. So the optimization is, again, in this case where there are no defers and loops, is that we're going to generate inline code at each defer, and at that defer, we're going to do, as we did before, which we're going to evaluate the arguments and the function pointer, but now we're just going to store it in some stack slots, so basically in some local variable space. And we're going to, the compiler is going to, of course, keep track of, where that data is stored. And the other thing we're going to do is we're going to store a bit in a bit mask that says this defer was activated. Okay, so this defer statement was run. So that's the way we deal with conditionals. And so as you're running through the function, you're storing the defer arguments and the function pointers, and you're storing in that bit mask what defers have run. And then at any exit, we generate, again, inline code that says, if this bit is set in the defer bit mask, grab these arguments and this function pointer from the stack slots and run it. And we go through in kind of last in, first out order, as defer is defined, to run those, any of the active defers. And one thing to quickly say, though, is that this is all at the compiler level that we put in those checks for the defer bits and stuff. So actually, if there are no conditionals, all the defer bit checks go away, because the compiler knows you set a 1 and then you checked for 1. And you set a second bit and you checked for a second bit. So they go away. You do have to still set the defer bits, because we're going to need to know about that stuff for panic and so forth. I can get into more details on that. But in the normal case, you'll kind of store all those arguments, set the defer bits, and then on the exit, you'll run those.
It was great. It's really clever. So making it work with conditionals is, I think, a bit of a genius move. I think that is a bit of a genius stroke, because I think it's quite clear that if you think about how could you optimize defers, then just statically have a look, see what gets called, and just put them in the exit points. It sort of seems quite simple. But to make that work with conditionals, and then with loops, that's got to be impossible, hasn't it? That kind of approach.
Yeah, you need some kind of runtime thing, because, of course, you're going to have to save an arbitrary amount of information, right? So you need some kind of linked list, which is what we already have in the kind of previous implementation, the more general implementation. So if you have a loop, you could call defer 100 times, and where are you going to put all that information? You're going to have to do some heap allocation and so forth.
So when you were deciding to support if statements, did you do any sort of like code analysis or anything to kind of say like this is something we absolutely need to cover? Or was it more just, we should probably just do it, so we did it? Yeah,
because I would have definitely said, right, well, if you can forget about conditionals.
I would have been the same thing. I would have been like, too much work up front.
Yeah, I see. We had the notion on the conditional first, and then a little bit along the way, we realized that for the case where there are no conditionals, all that code would kind of go away. So we realized, okay, it's not that much cost. And then the other thing is, you need the defer bits anyways, because you need to, in the case of a panic, you need to know, how far in the function you got, how many defers you ran, and so forth. And so you're either going to have to look at some stack thing, or you're going to have to look at the defer bits to know. We can get more into that about what we do for the panic. But in the panic case, you're many frames up and you're doing this panic and you're going through the stack, and you need an easy way to know which defers are actually active. So the defer bits made sense for a number of cases, and the overhead, especially panic, and then, the overhead, some of the overhead, a bit of the overhead goes away anyways in the non-conditional case. So we do have a mix. I did not do it percentage-wise of in the Go library of how many have conditionals, but there certainly are a fair number.
So when you were considering conditionals, do you consider panic a conditional then? In a sense that, I guess technically you'd have to have an if statement for that panic to become conditional. So that would kind of, or I don't know if a runtime, technically you could access an array index that's not there or something. So I don't know. Does that make sense?
Yes, you cannot know statically that a panic's going to happen, because there might be some reference past an array bound or something. I would say panic is conditional in the sense that that's kind of why also we need the defer bits, which is, or some mechanism to figure out how far you've gotten into the function. There are other ways to do that, but the defer bits works out well for both. That in either in a normal exit or in a panic exit, you can look at the defer bits and it'll tell you how many defers you've run into and how far down you've got.
So is it one thing that runs at the end at any exit point? Does it, do you know what I mean? Or do you literally copy the instructions?
You literally call each of the functions. So it is not just one big function and then that function calls a bunch of functions. Currently, and there are many choices. We could change this in the future with respect to the compiler, but right now we're literally calling the functions in the last in, first out order, and depending whether it's conditional or not, it may be depending on the defer bits or not. But so you're basically saying, if this bit is set, run this, your second deferred function, and if this bit is set, run your first deferred function. And then if there are no conditionals, then it will just be call for second deferred function, call first deferred function. So in the simplest case, it's very optimized in that sense, and kind of what you might imagine. And there's always certain choices, more optimization that we could do, or there are other ways of doing it. And so we can certainly analyze further to see what's best, but it's working out reasonably well.
It's funny because I wrote myself a little tool which took my Go code and did the first optimization that you talked about, where it just would comment out the defer line and then copy the, it was very rudimentary. It was just kind of an experiment.
No, that's actually a good point. That's exactly what people do a lot of times is of course, the defer overhead is showing up in their profile. So then they do exactly what you said, which is they take the defer statements, comment them out, and put the functions at the end. And so, this is good that we're doing this compiler optimization.
They do it manually, though.
Exactly.
I had a tool that did it for me. No, but genuinely, so my source code would stay looking with defers, so it was readable.
Oh, I see.
It was an automatic part of the build process.
A post-processor.
Kind of, yeah. Yeah, that's why I didn't tell anyone about it.
Yeah. Okay, well, hopefully you can not do that as much, maybe, with the optimization, and because the other important thing, of course, is you might not put it in all of the exits, or you will, because you're doing it automatically, and you're also not dealing with panic as well. So, we'd rather, especially if you're deferring an unlock, and you want your web server to continue on, you really want to make sure that unlock happens, because that thread that's about to die, but you're going to continue the web server, might hold on to a lock that's important for all the other threads.
If you like this show, I bet you'd enjoy listening to Brain Science. Join clinical psychologists Muriel Reese and Adam Stacoviak as they explore the inner workings of the human brain to understand behavior change, habit formation, mental health, and being human. Here's a quick taste of what you can expect. It's from episode 4 about coping skills and strategies. Take a listen.
I often use this acronym with people when they're trying to cope, and it's HALT, H-A-L-T, HALT. Because if we are hungry, angry, lonely, or tired, your coping will invariably look different. I don't care if you're 3, 33, 73.
Right.
If you are hungry or hangry, angry, lonely, or tired, you just have less to be able to navigate it.
Brain Science is a great podcast. Check it out at changelog.com/brainscience, or just search Brain Science in Apple Podcasts, Spotify, or your favorite podcast directory. You'll find it. While you're at it, upgrade to our master feed at changelog.com/master and let your podcast app download all the shows we produce. Then you can pick and choose the ones you're interested in the most and skip the rest. What have you got to lose? All right, back to the show.
When you guys were deciding to actually make these optimizations, was it because you were seeing people do what you're saying, like they were commenting these things out and doing that, and was it because you wanted to make sure code was more correct, or was it because you thought we want code to stay readable, so we need to improve on that? What was the motivation, I guess, behind improving this when arguably somebody could do what Matt said and get rid of it themselves if they really wanted to?
I think pretty much everything you said. I think the main reason is we don't want people to remove a defer for performance reasons when it's going to make worse readability, and it could make it incorrect in that web server case at least, and other cases, right? So, the main thing I would say is readability. You'd rather, this feature is great, and we'd rather people, are using it, and you get that readability of the lock and unlock, and not just readability, maintainability, right? Once you move it, the unlock to the exits, what if someone adds a new exit, a new early return, and they forget to do the unlock, right? So readability, maintainability, and then, and the maintainability, that's a correctness problem too, and it's especially a correctness problem that's really hidden if it's a panic, right? And, maybe this is a library and, they figure, we don't need to deal with a panic, but then you put that library in a web server and you want that web server to keep running even after one of the threads has had a problem. So all those reasons.
We have a question from a live listener. Is there a way to call defer only in the case of a panic? So you only pay the penalty when it's needed?
That's a good question. No, we don't currently. There's nothing in the language. That was kind of a little bit what Matt was saying. Any way to stop defers. There's no way to stop defers. Yeah. So you you have to run that code, and the thing is you just do a quick check, of course, but you do have to run the deferred function.
How expensive is it? And obviously I don't mean cash, although I'll be clear, I will still pay for it. It's that good. But how expensive is it, like, before your optimization?
Yeah, I can give you some numbers just on a Linux AMD 64 machine, pretty fast. So the rough numbers are that a function call might take 1 nanosecond. So obviously, we have very fast processor, gigahertz processors. Function call might take 1, 2, 3 nanoseconds. If you then, a defer call has been getting faster and faster over the past time, but even with stack allocated defer records, which is 113, the defer overhead plus the function call is about 35 nanoseconds. Okay, instead of 2 or 3 nanoseconds. So if that call is a call to unlock, which takes another nanosecond or two, then you have the unlock call and the function call take a couple, 3 or 4 nanoseconds, and the defer itself is taking 35 nanoseconds. And then with the optimization that we've made in 114, the extra overhead is just about a nanosecond. So now, the call plus the unlock maybe 3 nanoseconds, and another nanosecond is doing the defer bits and storing it to the stack and checking the defer bits and all that.
Wow, that is amazing.
It's a really good optimization. It doesn't, if the function call is much more expensive, it doesn't matter. These are nanoseconds. But if the function call is very inexpensive, like a lock or unlock, it does matter.
Yeah, so that's a good point for any people that are new to Go that might be listening. Is you hear these numbers and think, well, these nanoseconds, it doesn't make it's not going to matter at all. But of course, if you think about that at scale, imagine you've got either loads of users or you're doing loads of work. Of course, it just sort of adds up. But from that down to just 1 nanosecond for defers, that is genuinely exciting.
Yeah.
The interesting thing about performance numbers like that is, like, most of the time, those performance numbers or even like memory allocations, that sort of thing doesn't matter until when it does matter, it really, really matters. So that's the hard part, is it's when it does matter, it's a big deal.
I see. Oh, and also, I think the original part of the question was, have we seen this? And yes, even in the Go GitHub, the repo, the Go language itself, you see this. Both in the libraries, people have removed defers for performance reasons. And, definitely you see it in other Go projects. People will do it. And, sometimes it's not totally necessary. They see defer overhead, but it's like 1% or 0.5%. But they still feel like, in the profiler, they still feel like, okay, I want to change this defer. So we'd rather not have people remove the defer to eliminate that 1% or 2% or whatever overhead that they see. So hopefully now, they will not see that overhead and there'll be no motivation to remove the defer.
Will we see people putting defers back into the standard library, do you think?
Yeah, right. I think we should. Yeah. So that will be next release, yes.
Yeah. Do you think with this optimization, we can start to say that we're reaching RAI performance on par with C++, or we are on the way to doing that?
Yes, I think so. I think... Yeah, it's much more of the overhead that you would expect kind of from the normal semantics, and just like C++ and so forth. So I think there are more optimizations to do, and the GCC compiler, which does C++, of course, has been evolving for years and years and years and all that. And there's also a trade-off of like how much information you store on the side and so forth. To make exceptions and zero overhead in GCC took a number of years, and it requires information on the side, which we have as well, but they have a lot of information and stubs and so forth. So, yes, I would say we're pretty close, and we're quite close, as you can see from those numbers. And there's maybe little optimizations we can do further.
It's great.
So, when you're making changes like this, how do you go about testing it to make sure, do you know what I mean? Because obviously, if there was a bug in this, it could be a really big deal. So, how do you go about making sure that that's actually reliable and that you're not breaking anything?
Yeah, I think, the Go builders are an awesome resource. Obviously, all the tests already in the Go source tree, and then I added a bunch more of defer tests. And, being in Google, there's also an advantage you have of the whole entire Go source code to kind of test. So that's an advantage we get inside Google, not that you don't have outside. And that's kind of a little more packaged up. You can kind of run tests on that in a kind of methodical way. So you really just have to kind of go through all the cases and write test cases for them, and then run through a really large amount of code. And then, running on all the architectures, the Go builders really helps as well because you get a variety of timings. The Go builders have tests for, running on different kind of distributions, and then long tests and the short tests. And you can run with debug mode, sort of all the debug flags enabled and disabled and so forth. So I wouldn't say there's a magic bullet, but it's running on a whole variety of tests and a whole variety of situations.
And it must be rewarding to know that if you can make any difference there, that given how widespread Go is, the impact that has is massive.
It is nice. Yes, definitely. It's nice to have an effect on a whole large ecosystem.
Yeah. And what's nice from our side, from the user's point of view, is we get to just use these language features, and the nice people in the Go team are going to keep squirreling away, making it better for us, making it faster.
And it's nice to, you realize also, anything you can do so that a new person to Go doesn't run into a problem, right? A mistake or whatever. You make something that doesn't, they don't have to learn that defer is slow or something. They defer is absolutely what you want to use. So it's nice to attack those problems.
So I assume this means that, like with the beta release, it's going to be very important for people to test it too, just to sort of double check that whole thing.
Yes.
Is that out yet, or is that later?
Just about alpha.
Let's see. I'm double checking.
John, you've turned into like a new tech manager. You're like, have you checked it for bugs? When's it going to be ready?
This is one of those things where it's fun to grab and try it out and make sure it's still working. And I think
welcome feedback, absolutely, because there might be some obscure case. Yeah.
I need to double check. We were targeting for the beta 1 this week.
Okay.
So I think maybe in the next couple of days, beta 1.14 will be out.
Okay. I also think having more people run the beta versions is very useful. And since we have people listening, it's nice to tell them, go grab it, use it, try it. Just because the more people that use it, the more likely we are to prevent bugs and things like that from being slipped in.
Exactly. We want to hear about all bugs.
Right. And this is one of many runtime changes that are being made for 1.14. So
yes, there are memory optimizations and some other optimizations respect to delays. It's called asynchronous preemption, but delays in running the garbage collector and so forth.
Yeah, for the scheduler. Yeah.
I want to see time sleep optimized because it can really take a lot of time. That can.
All right.
No, I mean it. Yeah, sorry, it's been stupid. I wanted to say thank you for all the effort that goes into these things because genuinely, it makes a big difference, and it's nice to know that there's good, smart people working on these hard problems for us. So I mean that, Dan. Thank you very much.
Oh, thank you. Yeah, the team is pretty amazing. I mean, they're both inside Google and outside Google, and obviously over many years, it's just been optimizing continually. So it's very nice to help out and hopefully improve someone's program and so forth.
That's great. I'm going to ask live listeners if they have any questions to please put them in GoTime FM channel now, ask now, or forever hold your peace. We have especially performance channel. We have a very live and active Dan. I'm not sure if you're in Gopher Slack at all, but the performance channel is quite lively, giving them a little shout out.
Okay.
And they were quite excited to have you on as well. I don't think as excited as Matt, but almost as excited.
Yeah, I mean, I've had strong words with people on this subject. I actually advocate for it a lot, and sometimes people would be upset by the performance thing. Naturally, I dig into their use case, and it won't, in that particular case, it won't make the slightest bit of difference to them. But it does make a difference to people, and so now it's that. I mean, that is a massive optimization. So I really feel like that has now gone. We can now. There is no reason to not use defers. So. Yeah,
it's getting rid of that, especially if any of those people happen to teach or anything like you don't want them to teach that and then somebody be like, oh, I shouldn't use that and not really understand why they shouldn't be using it. Or, like we mentioned, if you're opening a file, it doesn't really matter.
Yes.
But there's a lot of people that probably don't even realize that because somebody else got bit with a lock or something else and told them don't do it there. And especially junior developers, we talk about that a lot where they just don't understand necessarily why they shouldn't use it. So they're just like, oh, I don't use that now.
You don't want them to have this vague idea that, defers are bad or something.
Yeah, because once they get that vague idea, it's very hard to change that perception in that mind, right?
It is there. It's in. It's already here. That's the thing. That there is now a challenge going to be. I think because I've seen it already. I've seen this. There's already this now religion against defer. So we're going to have to go and find those churches and.
We're going to proselytize. We're going to have to proselytize.
I think the first stop is Performance Channel and Go for Slack. I think that is going to be where the message will be sent. Like, please test beta 1. Go at 114.
Use defers.
Use defers to your heart's content, just like Matt Ryan.
Yes, and
then I already was.
And then profile your program and see that measure and see that there's the defer overhead is not showing up. So
yeah.
This means the Go standard library could have a lot of first-time contributor changes that are all just putting the defer back in and getting rid of everything else.
Oh yeah. Okay. Yes.
I sense a hackathon coming on or some kind of fun. Yeah, giving ideas, John.
Yeah, the defer events tend never to happen. I don't know why that is.
Nice.
Oh, that was dryly and perfectly delivered, Matt. But
actually, is that why you like defer so much? Are you a procrastinator?
I'll tell you later.
Wow. I really think that Matt missed his calling as a stand-up comedian. Totally. Yeah, funny.
I mean, he can still be one. He just has to choose his audience very wisely. It's got to be a tech audience.
Well, he has GoTime FM. I think the funniest low-key podcast out there.
Thing is, in tech, no one likes a stand-up comedian. You just want them to get on, tell us what you did yesterday, tell us what you're doing today, and if you've got any blockers, and get off. You know what I mean?
Aww.
No one wants the... there you go, see? That's why I didn't. I'll stick to programming.
I mean, there's only 3 people here. You might have a whole audience that's live listeners that's laughing right now.
Oh, yeah, let's assume that. I'm pretty sure this could be edited to make me not sound like an idiot, I think.
No. You know what we need? We need 1990s sitcom audios, right? Like the 1990s with the laughter.
Laugh track.
Yes.
That's what Dan said earlier.
I'm going to have to I'm going to have to buy a bigger monitor if I'm going to put a soundboard on here as well.
Yeah.
Maybe we can ask for post-production for our lovely show producers to do a nod to like some fun 90s sitcom with a laugh track. It would be fun.
That's a great idea.
Okay, so I'm not seeing any questions, so I'm just going to go ahead and wrap this one up. Thank you, everybody, for joining us on GoTime. We hope you'll come back next week and come join us live sometime in the GoTime FM Slack channel on the Go for Slack.
All right, thank you for tuning into this week's episode of GoTime. If you're not yet, hang with us in Go for Slack. We have a channel called GoTime FM. Look it up, you'll find us. Hang with us during the live shows, connect with other members of the community, share stories, share code, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions at changelog.com on every episode. Head to changelog.com/GoTime, find this episode, and discuss it with the community. Also, thanks to Fastly, our bandwidth partner, Rollbar for helping us move fast and fix things, and Linode for hosting the Changelog platform. Our music is produced by the mysterious Breakmaster Cylinder. And if you want to hear more awesome podcasts like this, subscribe to our master feed. It's one feed to rule them all, plus some extras that only hit the master feed. Head to changelog.com/master or search for Changelog Master in your podcast client. You'll find us. Thanks for tuning in. We'll see you next week.
And then I think there's music there or something. I don't close this thing out very often, so I don't know.
Yeah, I think, yeah.
Okay.
I mean, hopefully yeah, we rely a lot, Dan, we rely a lot on post-production.
Yeah.
Yeah.
You haven't done laugh tracks yet, but
Not yet.
Not yet.
This
Not
might
yet, but
be
you
the
gave us-
one.
I see.
Yeah.
I think we've deferred the laugh tracks to this episode.
That's
deferred,
going in.
yes.
That's going in the show.
Oh yeah, I try.
We should have like at GopherCon. We should have like a comedy thing where people can write jokes about Go.
Oh my gosh,
I'd love that.
I think so too.
Instead of the lightning talks, have like a small section for like lightning comedy.
Lightning jokes.
Yes, that would be great.
You could try and change the trend where all the jokes are about go and going and all that, and now you have jokes about
Yeah.
defer as well.
Yeah.
Yes, exactly.
Yeah,
Yeah, no
second
puns.
keyword.
Yeah, we could totally move beyond. We like Go puns are so 2019. We're totally needing 2020.
Yeah, we need new comedy. Yeah, absolutely. Like, yeah, I can't think of anything. That's why we need it.